In this video, I'll be solving the third part of the third question of UPSC Civil Services Mains 2021 Statistics Paper 1. So let x1, x2 and so on xn be a random sample from uniform distribution minus theta comma 0 minus theta comma theta. So we need to find the complete sufficient statistic for theta, and also we have to obtain the best unbiased estimator of theta. So suppose if x1, x2 and so on xn, so they are following IID uniform minus theta comma theta with this theta greater than 0. So that means if we consider m as like maximum of this mod of xi, where 1 less than or equal to I less than or equal to n, so then the joint PDF of this sample is nothing but, so f x1, x2 and so on xn comma theta. So this is nothing but pi I is equals to 1 to n 1 by 2 theta into indicator of this xi mod of xi less than or equal to theta. So that's nothing but 1 by 2 theta whole to the power of n into indicator of this m less than or equal to theta. So that means this, by using this factorization theorem, we can say m is a sufficient statistic for theta. So now, like, if we find the distribution, like in order to check the completeness, suppose let x, so let zi be like mod of xi to find the distribution. So zi follows uniform 0 comma theta. So now for 0 less than or equal to m less than or equal to theta, like for some small m, so I can say probability of this capital M less than or equal to m is nothing but, so the maximum of the, so the nth order statistic is less than or equal to m. So that means so that is nothing but probability of x1 less than or equal to m, x2 less than or equal to m, and so on xn less than or equal to m. So that means our probability of m less than or equal to m would be m by theta whole to the power of m. So that means this PDF of m is fm of m, which is n times m to the power n minus 1 by theta to the power n for 0 less than or equal to m less than or equal to theta. Now suppose like g is some measurable function, so expectation of g of m is equals to 0 implies integral 0 to theta z of m into n to the power m to the power n into m to the power n minus 1 divided by theta to the power n dm is equals to 0. So that means n by theta to the power n integral 0 to theta g of m into m to the power n minus 1 dm is 0. So that means like for every theta greater than 0, this integral must be equal to 0. So if I consider g of theta as 0 to theta m to the power n minus 1 g of m dm, so this g of theta should be equal to 0 for all theta greater than 0. So if I find the differentiation of this is theta to the power n minus 1 z of theta is equal to 0. So that means z of theta is 0. So that means m is complete. So m is sufficient and m is complete. So now by using Lehmann-Scheffé theorem, so by Lehmann-Scheffé, so any unbiased estimator, any unbiased function of complete and sufficient statistic m is unique UMVUE. So that means if I find expectation of m, that is integral 0 to theta m into nm to the power n minus 1 by theta to the power n dm, that is nothing but n by theta to the power n 0 to theta m to the power of n dm. So that is nothing but n by theta to the power of n m to the power n plus 1 by n plus 1 from 0 to theta, which is n by n plus 1 theta. So that is our expectation of m. Now m is biased, but if we see like n plus 1 by n into m, so that is theta. So that means n plus 1 by n into m is unbiased. And we can clearly see n plus 1 by m is a function of complete and sufficient statistic m. So that implies n plus 1 by n into m is a unique UMVUE, the best unbiased estimator of theta. So n plus 1 by n into m is the UMVUA of this theta. So that's it. Best unbiased estimator of this theta. So that's it for this video. We'll meet in the next video.